This is a very difficult question. We've got a matrix, and they've told us that some point gets transformed into this point. So let's get our head around it. First of all, a matrix will transform any point you like to another point by matrix multiplication. So this point is this matrix times 3, 4. 3, 4 gets moved to minus 10, 13. Maybe that's part of a rotation. However, let's say the question said, a slightly easier question than this one. It said something like minus 6, 5, saying which point gets transformed into minus 6, 5. So I don't know what to put in here. There's two ways of doing this question. Can I find these two? Well, one way is I can just give them names. Let's call it x and y. And now I can multiply that out. Now, can you multiply out a matrix? And so we go across the first and down the second, 2x minus 4y. And then we go across the first and down the second, 3x plus y. And now I've got simultaneous equations. 2x minus 4y equals minus 6, and 3x plus y equals 5. I could solve that. That's one way of doing it. The other way is to realize I can move this here. This is matrix arithmetic. Can I divide by this matrix? No. So what do? You multiply by the inverse of it. Now, if I multiply by the inverse on the left side of both sides of this equation, multiply by the inverse, this one will disappear, and it will appear here to the power minus 1. So I've moved the matrix over. So I've shown the working here. There's my original question. I want to move a matrix from the left side to the right side. So I left multiply by the inverse. It must be left multiply. I can't put this matrix on the right-hand side. And now that can be typed in to find the answers. That's a really nice method. So let's upgrade this question. This question is saying that some matrix, some 6 minus 5t. So we've got to solve this equation here. And what we're trying to do is find, well, which point was it that got transformed to be here? And they're trying to stop you using your calculator. So I think the first method is the best one. Let's do that. I'm going to multiply this matrix. So here it is. Let's do this matrix multiplication across the first, down the second, 2x minus 4y. And then you go back to the next row and you go across the first, down the second, 3x plus y. And now this does look like a difficult question. You say, well, what's going on? I've got 3 variables, but the question says leave your answer in terms of t. So in fact, it is just straightforward simultaneous equations. So I've extracted them from the matrix. This is simultaneous equations. I think the easiest way is probably to say that y is equal to 6 minus 5t, take away 3x, and then substitute that in. So I've substituted this y into the top equation. It's a bit of a mess, so I multiply it out and then collect the x's together and find it. There's x, and we'd have to find y. So it's a very difficult question. Let's just briefly go through the key points. That matrices transform space by this equation here. And normally you're told the coordinate, and you simply multiply by the matrix, and you can find where it goes to. In this question, though, it goes the other way around. And so we can multiply by the inverse, left multiply, and then we could have multiplied those two matrices together to get the answer. Or we can simply multiply it out with this x, y in it. And then this is simultaneous equations. They've just made it a very difficult one.